Hello, my name is Jordan Stevens, and I am doing my introduction and concept mapped for my final project for Engineering 300. I'm going to start off with the introduction to the problem. Forest fires are a major issue for many parts of the country and can cause millions of dollars in property damage, but also ecological damage in national parks. If national parks and forest rangers were able to predict not only based on the fire danger scale, which is already established, but a probability of fire in a certain area, it would greatly increase prevention of these forest fires, which it would in turn increase protection against ecological and economical damage. In this project, I want to use the FWI, the Canadian Forest Fire Weather Index, date, temperature, and weather, to accurately predict a forest fire based on proper probability from 0 to 1. This approach will need logistical regression in order to solve it. In this project, I will do a literature review of a data mining approach to predict forest fires using meteorological data. I'll use the data methodology and data mining in this paper to predict forest fires. This will diverge from the paper's prediction of burnt areas by already known fires. So I'm going to go into the literature review. The paper that they show first goes into an introduction about the importance of and the need to predict forest fires and how this will help national parks and how it help protect against ecological and economical damage. Then they go into how they will gather the data and what the actual FWI or the Fire Weather Index is and how good of a scale it is for predicting fires. After that, they go into data mining, and they go into how there's been a very large advance in information technology, and with that growth will come more accurate predictions from neural network models and SVM, which is a support vector machine. They diverge from neural networks and they go into SVM, which is a more complicated method, but has higher accuracy and higher processing speeds. After that, they go and explain the actual variables that will be the inputs for the neural network. They start talking about variables that are associated with the fire weather index, which I'll talk about in the other video. And then they go into explanation of what the X and Y coordinates mean. They worked on a national park that's in Portugal. I think it's the Montencino Park, which has a lot of forest fires, regular small forest fires, which makes it easier for them to predict forest fires in a certain area. And they use a lot of variables based on past forest fire and past data to predict future values through a neural network. Where I diverge from them is they will accurately predict the total burned area from an already known fire, where I will add data that is from days that aren't associated with fires, and I will associate a probability of a fire instead of a total burned area from fires. Then they go into their error testing and RMSE, the root mean squared error, and the MAD, which is the mean absolute deviation, which is their error measurements that they'll be using. After this, they diverge and to go into SVM, which is a very, very complicated method once I researched it, and I believe that it's beyond the scope of this course. This is a very complicated method with a lot of error testing and exponential and logarithmic notions. It is a lot more complicated than a neural network, and but it was a lot more accurate, and it's proven more accurate. Then they go into their results, go into the error testing, and their model has, their model has a high accuracy. I think it's around 80% if I read correctly in the paper. After this, they go into their conclusion, basically saying that these are good things and that these local sensors and scanners and things for meteorological data will help the ability to prevent forest fires. So now I'm going to go into my approach to the project. I would use a lot of the similar techniques to the paper, except for SVM, but I will diverge into my own problem that will predict the probability of fire in a certain area rather than the burned area by an already known fire. First, I'll collect more data. Since all the data presented in the paper is of known fires, I will find data of days and areas that do not have fire in the same national park at the same year of the data collected, which was from 2000 to 2003. To find this data, I went to the same site that was used in the paper to find the FWI values, which is in the references below. It's a website. And after I created the complete data set, I will normalize the data and use the MATLAB form-fitting neural network tool to predict future fires based on these variables given. So here's just a simple Excel file, which basically I'll link to MATLAB, and this basically shows all of my variables that are highlighted in the top up here are the input variables and predicting variables. And the fire one is a 1 means that there is a fire, and a 0 means there wasn't a fire. So it goes into logistic approach since there's only 2 options. After this, I went into my concept map. My concept map's pretty easy to follow. I have my input variables. I have 12 input variables here that will go into a form-fitting neural network. The number of neurons are to be determined. That's kind of a finesse thing. Certain neurons work better for certain problems. And I only have one input, which is the probability of fire, which is between 0 and 1. And here's my video link that I'm going to post, and here's my references. This is the actual paper. This is the site I found my data from, number 2.